The next 3 videos are examples of designing a function that consumes non-primitive data, data that's defined by your own data definition. Now, they're HtDF problems, so mostly you know how to do them. Remember, I said the HtDF recipe is largely orthogonal to the form of data, but it isn't completely orthogonal to the form of data. One real dependence between function design and form of data has to do with the number of tests that's appropriate for that function. So in these videos, I'm going to pay particular attention to the number of tests that we're going to use based on the form of data. I'm in ILStarter.racket, and the problem we're asked is to use the seatnum data definition and design a function that produces true if the given seat number is on the IL. So the first thing I would do is go look at the seatnum data definition, and it reminds me that seatnum is a natural number from 1 to 32 inclusive, and that its seat numbers in a row, and 1 and 32 are the IL seats. So now I can get started on my function. I'll quickly do the signature, purpose, and stub. Let's see, it's going to consume a seat num, and we're supposed to produce true when the seat number is on the IL, so that means it's going to produce a Boolean, and it'll produce false when the seat number isn't on the IL. And let's see, produce true if the given seat number is on the IL. And let's see, the function, this is a predicate, so we'll name it using the naming convention for predicates like this, IL question mark, the seat number is, and we'll just produce false for the stub. So let me run that to make sure the stub is well formed, and it is. Okay, now let's get to the examples. Now here's the first place where the data definition is really going to have something to say. If we go back to the How to Design Data page, and we go to the section on intervals, and we go to the section on guidance on examples and tests, it tells us that when writing tests for functions operating on intervals, we should be sure to test closed boundaries as well as midpoints, and always be sure to include enough tests to check all other points of variance. So let's go back to the code. I've got an interval with 2 closed endpoints. So I know that what I'm going to need are 3 tests. One for the first closed endpoint, which is 1. One for the middle, which is, middle doesn't have to be the exact middle, something like the middle, I'll call it 16. And 1 for the closed upper endpoint, which is 32. And now what are these going to be? Well, I'm supposed to produce true if the given seat number is on the IL. Let's see, this one is on the IL. This one is not. And this one is. Notice how much information the data definition gave me about generating the tests. Data definitions are always going to be helpful this way. They're not always going to make it quite this straightforward. But data definitions, the structure of the data definition, the structure of the data, tells us a lot about the tests we need. So let me run that. Good. They're all running. Now for the template, what I'm going to do is I'm first going to comment out the stub. I'm going to say use template from seatnum, and I'll just leave that note. I'll copy the template down, and I'll use it like that. I have to rename it to be IL, because that's the name of this function. And let's see, I'm consuming a seat number, which is a natural from 1 to 32, and I need to produce true if it's an IL seat. That means I need to produce true if seat num is 1. Also, seat num is 32, and I just need to OR those two together. Let's try that. All 3 tests pass. So there you go. That's designing a function that consumes an interval. And the big piece of help we got from knowing that's an interval is, well, of course we got the template, but we also got the structure of the tests. In this case, it's an interval with 2 closed ends. So we have a test for each of the ends and a test for somewhere in the middle.